pick up where we left off here. On I, lesson 3.1. To recap what I did to get myself back in the groove. I had just looked at the fact that it's cosine squared and sine squared, so for the purpose of what we're doing here, I rewrote it as cosine of 4x quantity squared minus sine to the 4x, or sine 4x quantity squared. And that's more than anything just to show what the outside function is. So then, on cosine 4x quantity squared, the outside power is a 2. So when it's power of 2, move the 2 out front, keep the inside the same, subtract 1 from the power, so times 1. And then, unless that inside is just a plain old x, we have to do the chain rule, derivative of cosine of something now. Derivative of cosine of something is negative sine of something. But then, one more time, since there's a 4x here, it's not just an x, what's the derivative of 4x? That's a 4. Now, what I did, and this is just an aha moment here, basically I just carried down this minus sign. I just said, okay, this minus sign is going to carry down. And then I looked at, okay, what's the derivative of sine of 4x quantity squared? I'm not really thinking of it as a negative or anything. I just carried that minus sign down, and I'm worrying about this. So then I was saying it's 2, or something to the second. So 2 times that something raised to the first. Then times the derivative of the inside. So the derivative of sine of something is cosine of something. And then we had one more piece. We just did the derivative of sine of something, got cosine of something. What's the derivative of something? So what's the derivative of 4x? And that is 4. Are we okay with what I've written here?
Yeah.
And I think me saying, I think maybe the disconnect, I'm just calling this a minus sign and just carrying it down and then ignoring it pretty much. I think that's the easiest track here. Now, cleanups. Are there some cleanups, I'm guessing? On the first piece, I see a 2, a 4, and a negative that I can put together. So I'm going to say negative 8. It's cosine 4x, sine 4x. Okay. And then on the next piece, okay, if I currently carry down my minus, besides that I see a 2 times 4. So I'm going to say 8 sine 4x, cosine 4x, if I just write what I have there. And
I'm just thinking negative 16.
Yeah, are they like terms? They are. I have one written as cosine 4x sine 4x and the other written as cosine 4x sine 4x, but they are like terms. Negative 8 minus 8 is going to make it negative 16. So negative 16 cosine 4x sine 4x. Or it could be written negative 16 sine 4x cosine 4x. Are we better on that one now? Okay. Difficulty is increasing. On J, let's talk about it before we do it. Y equals x to the 4th sine squared x. There's multiple issues going on here. What do we see?
There's no obvious outside.
Okay. And as we look at this, is this all just one function?
No.
No. We have to realize that this is x to the 4th times sine squared x. Which means, and it could also be written as x to the 4th times sine x quantity squared. Which means before I consider chain rule, This is two different functions being multiplied together. So I have to think product rule first. Okay? So product rule says derivative of the one, keep the other. Plus, and then we flip it. Yes? So, if we start with x to the fourth, what's the derivative of x to the fourth?
4x to the third.
4x to the third. Do I need a chain rule on that piece? No, because it's just an x we're taking the derivative of. So no chain rule. The derivative of x is just 1. So derivative of x to the fourth is 4x to the cube times the sine squared of that. Then product rule has a plus in it. This time I'm going to keep the x to the fourth. And I'm going to multiply by the derivative of sine squared.
2 sin x.
So derivative of something raised to the second is 2 times the something raised to the first times, do I have to use chain rule here? Yeah, because what was raised to the second? Sine x. Sine x is a function you can take the derivative of. So what's the derivative of sine of x?
Cosine of x.
Cosine of x. Okay? So in that one, we used the power rule first for the power of the second, but then we had to do derivative of sine x. Now, did we get all the pieces, I think? Okay. So clean up. The first term, I would probably just say 4x cubed sine squared x plus, on the next one, I personally would put the 2 out front and then say 2x to the fourth sine x cosine x. We could leave it like that. Or, I'm not sure how helpful it'd be, but I do have an or written in my notes, and that is there's a GCF that could factor out.
Sine x.
Bigger than just a sine x.
X cubed sine x.
Bigger than just an x cubed sine x.
And 2x cubed sine x.
There we go. So we can factor out GCF of 2x cubed sine x. And again, I say it's an or. I'm not saying you have to do this, but you have to be able to recognize it, of course. So when I do that on the first term, I'm going to be left with
2 sin x.
2 and sine x. Plus, on the second term, I'm going to be left with
X cosine x.
x cosine x. So we have the first answer or the factored version. They're both good. They both have their reasons. Okay. Continuing along. We're getting to see just a big variety of problems. Are we good?
How did we get on the first step 2 sine x times cosine x?
So
I get the 2 sine x.
So yeah, because the 2 sine x was the derivative of something to the second. You move the 2 out front, subtract 1. Technically, it's a 2 sine x to the first. But then it's a chain rule because it was the derivative of something to the second, which is 2 times something, and then times the derivative of the something. So the derivative of sine is cosine.
Okay.
It's a chain rule we learned yesterday.
Okay.
Where if you have something on the, you do the derivative of the outside function first, and then the inside. Yesterday we were cooking. Today I feel like we're struggling.
They're getting more complicated.
Well, that too. They are. They are definitely getting more complicated. We're not done getting more complicated yet. So, okay. Okay. H of x equals natural log of natural log of x. Okay. Natural, or h prime of x, derivative of the outside function. What's the outside function? This natural log here, yes? What's the derivative rule for natural log of something? 1 over x, or so I'm going to say it as 1 over something. 1 over whatever's inside. So in this case, it's going to be 1 over, what's my inside? Natural log of x. Times, we're not done. So outside is that first natural log. Derivative of natural log of something is 1 over something. Can I take the derivative of something? What was my something? My something was natural log of x. So what's the derivative of natural log of x? 1 over x in this case, because the inside is just an x.
Fair to say that this is getting paradoxical.
If I put this together, I would write it as 1 over x ln x. Okay. No. No, 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 no. Okay. Dang it, my water bottle squirted on my notes. Okay. Let that dry. Okay. F of x equals sine of e to the pi x. Okay. What's my outside function we're starting with?
Sine.
Sine. What's the derivative of sine of something?
Cosine of something.
Cosine of something. So cosine of e pi x. Now, so the derivative of sine of something is cosine of something times the derivative of that inside. So times the derivative of something. So now we're doing the derivative of e to the pi x. What's the derivative of e to something?
E to something.
E to something. So e to pi x. Now, I said something again, didn't I? So it was, what's the derivative of e to the something? It's e to the something. What's the derivative of something? Or in other words, what's the derivative of pi x?
Just be pi.
Pi, because pi is a number, right? So like the derivative of 3x is 3, the derivative of pi x is pi.
Gotcha.
And now, we just took the derivative of a plain x term. So we're done.
You got clean up.
I would probably clean up,
So just put pi out front.
put the pi out front. I was just looking to see, yeah, I put the pi and the e pi x out front. Just, and that's partially so it doesn't look like it goes in the cosine. I'm not saying you'd have to. But mine I have written as pi times e to the pi x times cosine of e to the pi x. It's about all the pieces. There's not just one proper way to write it. It's about having all the pieces.
Gotcha.
Okay? There are wrong ways to write it. Don't, I'm not saying there's not, but
Did we not see integrals fill after this?
correct. We do a crap ton of derivatives. Okay, m. G of theta equals 4 cosine squared pi theta.
Oh. Well, I might have it on this over this class, like, sway my beliefs.
Calculus is a definite for engineering, so. Okay. What is my outside function here?
-8 sine.
Wait,
8 sine.
Yeah.
wait, what's my outside function?
4 cosine squared.
Something to the second, yes?
Yes.
So pause your thought. You're doing two derivatives at once.
Yeah.
We got to do step by step here. So I'm going to think of this as 4 and times cosine of pi theta to the second is what I'm thinking of that as. Not saying you have to write that, but that's my visual. Because what so this is like kind of like saying this is with 4x squared. That's my outside function. How do I take the derivative of 4x squared? It's going to become what? This would be 8x. If we're doing the derivative of 4 times something to the second, what happens? 2 times 4 becomes 8. My inside, the first go round, stays the same. Subtract 1 from the power, and it's just 1. So my first go round, I'm going to be at 4 cosine of pi theta. Because that's a derivative of something raised to the second. Except it's not a 4, is it? What should that 4 be? It should be an 8. My apologies. I saw you kind of flinch at that, and you were trying to, so that was my clue that, wait a minute. Okay, are we better?
Yes.
So that's the derivative of something to the second. Now, what's my inside we have to concern ourselves with? Cosine of pi theta. What's the derivative of cosine of pi theta? Or what's the derivative of cosine of something? Negative sine of something. So negative sine of pi theta. And then, so we did the derivative of cosine of something, got negative sine of something. There's still something in here that's other than just a plain old variable. So the derivative of pi theta is indeed pi.
So probably like negative 8 pi cosine pi theta sine pi theta.
Yep. The only thing I would say, negative 8 pi I think definitely should be first. Whether you do cosine pi theta then sine pi theta or vice versa is flexible. Okay. In?
Yeah, I'm gonna change this because it's 10 parentheses 2x minus 3 quantity 1 half.
Okay. So thinking ahead that in order to do a square root derivative eventually, we think of it as 1/2. Okay. What's the outside function that we're starting off taking the derivative of?
And the 1 half. Sum of 1 half.
This 1/2 is part of what is inside tangent. The part inside tangent, the variable, is the square root of 2x minus 3.
Why is it any different if it's squared?
Because if it was squared, if the function was squared, it'd be right here, like a tan squared or a tan cubed. This is not, the whole thing is not, this is just a plain old tan, but what would normally be like your theta, like this whole thing here is in place of theta.
Gotcha.
So you're thinking of this as tangent of theta. Theta is just ugly. Okay, so
Secant squared.
So yeah, so you're starting with the derivative of tangent something
secant squared theta.
is secant squared of something, except secant squared of,
2x minus 3 1/2.
and if you want, we're not going to do anything with that physically. You can either say 2x minus 3 1/2, or you can go ahead and change it back.
I was gonna say, there might not be a reason to rewrite.
Well, there will be eventually for part of it.
Okay.
If you, on this part, if you wanted to go ahead and say square root of 2x minus 3, you could for that part. Okay, now, we're not done. We didn't just take the derivative of tangent of theta. It was tangent of something. So now, we've got to do that piece there. So derivative of the square root of 2x minus 3.
We didn't change to x to the negative 1/2.
Well, okay, so if we're doing the derivative here of 2x minus 3 to the 1/2, 1/2 is going to go, in other words, right now we're doing the derivative of something to the 1/2 power. So 1/2 out front, 2x minus 3, and then my denominator, my exponent becomes negative 1/2, because it's a power rule. Move the 1/2 out front, keep the inside, subtract 1 from the exponent. And then, do we have another inside?
2.
We haven't done the derivative of 2x minus 3. Derivative of 2x minus 3 is 2. And now, it's about putting this all together as a nice, neat answer. What can cancel? 1/2 and 2 can cancel and be gone. So that leaves me with the secant squared of square root of 2x minus 3 and the 2x minus 3 to the negative 1/2.
So the powers can't cancel, can
No, because this 2x minus 3, square root of 2x minus 3 is the variable of secant. It cannot separate from secant. So I can have a secant squared, square root of 2x minus 3. That negative exponent can send me to the denominator and have a square root of 2x minus 3 in the denominator. Okay. Okay, ready for the next page? Next page is, how do we use this chain rule when there are charts or tables, and compositions. So, 4. Let f be a continuous and differentiable function. They have to tell us continuous and differentiable, otherwise we can't necessarily do what they ask. We can't take the derivative if we don't know if this is a continuous and differentiable function. Okay, on the interval 0 to 1, just means all my x out values are between 0 and 1, let g of x equal f of 4x. The table below gives the values of f prime of x, the derivative of f of x. Find the value of g prime of 0.2. So here's what I would start with. You could start with the 0.2 in there, but I'm going to just say, let's start with the fact that g of x is equal to f of 4x, correct? They're asking me to find g prime of something. So let's come up with a rule for g prime of x. What's the rule for g prime of x going to say? If we're doing the derivative of g prime of x, that means we're going to do the derivative of f of 4x. What's the derivative of f of 4x going to be? Derivative of f of 4x is going to be f prime of 4x. And then what am I going to do? Times the chain rule, which says times the derivative of the inside, so times 4. Okay, so when you see something in there, you have to think, and that's why I haven't put the number in yet. I haven't put the 0.2 in yet because we have to get our rule. Now that we have our rule, you can go ahead and put in your 0.2. So the fact that in order to do g prime of 2/10, it's going to be doing f prime of 4 times 2/10, and then times that extra 4. So g prime of 2/10. I'm going to go ahead and move that other 4 out front.
So this becomes f prime of 0.8, right?
Yep. So 4 times f prime of 0.8.
So then it becomes 1.125 times 4.
Sure, if you say so. Yep. And 4 times 1.125. That is my guess. Are we right? My mental math guess was saying 4.5, and my notes agree with 4.5. Okay. So chain rule still applies. Okay. In there was a 4x inside, so you had to do the derivative of 4x, which was 4. Okay. Okay. Let's try example 5. Use the table to complete the following. So notice they give me f, f prime, g, and g prime, all for -1, 0, and 2. Find the equation of the tangent line to x equals -1 if h of x equals 3 f g f 3 times f of g of x. Ooh.
Exactly. Can't say that.
I
That's why-
can't.
That's how you know there's too many letters.
It's also Friday. Okay. H of x, let me write it out, is the given rule of 3 times f of g of x. Well, hello, we're doing derivatives, but equation of the tangent line means we need to know the derivative to find the slope of the tangent line, right? So, with that in mind, before you put the -1 in, find the rule for h prime of x. Okay. The 3, I would say it's just a constant, it just carries around out front. So what's the derivative of 3 times f of g of x? Well, what's my outside function? It's at f, yes? So derivative is going to be 3 times f prime of g of x. So we're doing the derivative of f, keeping the inside the same, times
The derivative of g of x.
the derivative of g of x, so g prime of x. That's how I would write out my rule. Now, officially, what do they need us to find? H prime of -1. So it's going to be 3 times f prime of g of -1 times g prime of -1.
Wouldn't you go a step further on that and get the derivative of x instead of the g of prime of x?
But the derivative of x is just 1. And so, I mean, technically the chain rule never ends.
Yeah.
Because then the derivative of x is, you keep going with it. But that's, once it's just an x, that's why we don't do it anymore.
So it'd be 3 f prime f prime of negative 1 times 2.
I don't know. 3 f prime of what'd you say?
Negative 1,
Okay, because g of negative 1 is negative 1 times.
2.
Okay. So we did our inside, and we did our g prime. Then you have to do 3 times f prime of negative 1.
3 times 4 times 2. 24.
Okay, I can go with that. 3 times 4 times 2 is 24. And so what is this 24 here? This was h prime of negative 1 technically, yes. Which is also going to be my what's it going to be in the equation of the tangent line?
Slope.
It's going to be your slope. Sorry, did you already say that and I missed it? My apologies. What else do I need besides the slope?
You need a y value.
We need a y value. My x value is negative 1. So I know that it's going to be negative 1 comma something. How do I find the y value?
Just put 1 in that first equation.
Okay, plug in negative 1. So we're finding h of negative 1, which is 3 times f of g of negative 1. G of negative 1 is negative 1. Then you have 3 times f of negative 1.
4. No, negative 2.
So 3 times negative 2. And 3 times negative 2 is
Negative 6.
negative 6.
So you get 1 equal, and y equals 24 parentheses x plus 1 parentheses minus 6.
Okay. Equation of the tangent line. We're always going to see that when talking about derivatives, right? Find the slope, find the point, put them in your line. Okay, one more. If j of x is equal to f of g of x times cosine x, what is the value of j prime of 0? Which means we've got to start by finding j prime of x. We've got a lot going on with j prime of x. Not only is there chain rule, there's also product rule. Did you guys catch that?
Yeah.
Okay, so if we start with derivative of f of g of x, derivative of f of g of x is going to be written down as what?
Prime g of x times g prime of x.
Okay, so the derivative of f of g of x is the outside, so f prime of g of x, keeping the inside, times the inside derivative, g prime of x, times cosine x. So that's derivative of the first, keep the second. Plus,
f g of x
we're going to keep the first, f of g of x,
times negative sine of x.
times the derivative of cosine x, which is negative sine of x. Okay? Now, we've got that written out. There's not a ton of cleanup, so I'd go ahead and plug in our 0. G prime of 0. Let's, every place you see an x, let's put a 0 and then we can work on it. Okay. I just wrote out with all my x's became zeros.
The whole second half is going to cancel out because negative sine of 0 is just 0.
Fair statement. Sine of 0 is 0. So I agree that that's going to make this whole second half 0. I don't know what f times g of 0 is because I haven't found that out yet, but it does end up becoming irrelevant. Okay. Now, on the first half, f prime, what is g of 0?
2.
So f prime of 2 times, what's g prime of 0?
Negative 3.
It's negative 3 times what is cosine of 0?
1.
1. Plus, if you want to go ahead and nix that whole piece out, I'm fine with that. Okay.
It just saves work.
I get it. F prime of 2.
Negative 2.
So negative 2 times negative 3 times 1
6.
plus 0, which is indeed 6.
All of that just hits.
Hey, at least it cleaned up nice eventually. Okay. 3.1. This is one that's longer than the notes.
It's ridiculous because you know they're just giving examples that aren't in the notes at that point. Like,
And some of it, I mean, but there's also just a lot of practice too.
35 questions for what?
Practicing.